Hello and welcome to our video on using morphing within HyperWorks 2022. We're going to focus on three tools under the morph ribbon here today: the free morphing, proximity morphing, and volume morphing. And we're going to be demonstrating their application on this NIAR fuselage aircraft model. The first thing we're going to do is just get rid of some of the 1D elements and connectors from the display here. So we're going to use the mask browser and simply click the minus button on the elements that we don't necessarily want displayed. They are still in the model, and any morphing changes that you make will still be included within the model and will be applied to those elements and connectors. But for the purposes of a clear display here, we're just going to turn those off. So first of all, we're going to demonstrate the free morphing functionality. So we're going to focus in on this particular bulkhead here. We're just going to isolate that bulkhead by selecting it from the display and pressing I. And what we want to do with our free morphing is we want to create change this 90-degree corner here into a rad curve here. And we want the mesh to morph along with that. So the first thing we need to do is just going to create some lines here that represent the corners that we want to morph to. So we go to the geometry panel, create polylines, and we're going to select the nodes that we want to use to create our line, our curve. Once we're happy with the curve that we've got, and we simply click the triangle here to accept that line. And we'll create one on the other side too. We select our nodes. Once we're happy with the line, we click accept. So we have our two lines that we need in order to perform our morphing operations. So we're going to go back to the morph ribbon now and select free. And then what we need to do is we need to select the nodes that we want to morph to that line. So we're going to select nodes here from this move drop down. And if we hold down the Alt key, we can select the nodes by path corresponding to the region that we want to morph. Now automatically, you'll see this automatic box here is selected. HyperMesh will automatically create anchor nodes based on the mesh that you've provided it with. You can modify those if you wish by unticking the automatic box and selecting the anchors here, and then deselect the nodes that you don't want to be anchored, or if you're happy with that selection, then you can leave it as is. So what we're going to do is we're going to deselect this set of nodes here because we want those nodes to move with the morph, but all the others we're going to leave as is, and we're actually going to add this node here to the anchor nodes. And then we're going to choose our target, which in this case is the line that we want to morph to. And then up pops a pop-up box with a morph to target icon here. We can choose some different options here if you wish in terms of the direction that you want to morph But since we have a target that we're morphing to, we can simply click morph. We click yes to that. That's just some warning or notice about the existing domains and morph volumes that are in the model. And there we have a corner added to the to this bulkhead. If we weren't happy with the mesh on that particular morph, then we could undo that, change the options here. Under the options, you have the choice to remesh. If you allow remeshing after morphing, and you have some options as to how HyperMesh decides to do that. You can morph after QA checks or just morph or remesh, every time. We're just allowed to remesh every time, and we're going to redo that morph. We press Control Y. So we're going to choose a line and click morph. And now we have a pop-up now. It says you want to remesh. You can review the elements that HyperMesh has chosen to remesh, and you can reduce those so you're not remeshing more than you want to. And then you can simply click remesh. And it will remesh that area of selected elements according to your mesh parameters within the criteria file. So we'll just do the same to the other side, just to show it again for you. So we select our nodes by path, holding the Alt key. Select a line that we want to morph to. Delete. So we just go through that on the other corner here, just so that you can see the process again. So we make sure that we tick automatic on the anchors. We choose the nodes by path using the Alt key that we want to morph. And we choose a target of our line that we want to morph to. If we want to change the selection of anchor nodes, then we can untick automatic, select anchors, deselect the nodes that you do not want to be included as anchors, and then click morph. And again, because we had remesh turned on, you can choose the elements that you want to remesh, or be included in the remesh, I should say. And then click remesh. So that is an example of the use of FreeMorph. We'll now go back to our full model, pressing C for components, A for all elements. I'm going to show you an example of the proximity morphing. So the proximity morphing is very good if you want to make changes to your mesh that will only influence a certain region within your model. So, for example, if we wanted to make a change to this bulkhead here, and what we want to do is we want to move this system hole here dam 30mm within this mesh and update the mesh accordingly. So we're going to choose proximity morph, and we're going to just check our option settings here to ensure that we've got the settings we want. So we have remeshing is turned on, and we're just going to remesh after we completed our morphing operation. And then want to select the nodes that we want to morph. So we're going to right click and change the selection tool here, left click on the circle, and then just draw a circle around the nodes that we want to morph. And HyperMesh will then automatically choose all the elements that are going to be impacted by that morph based on the buffer setting here. So what's been selected is fine for our purposes here, but there are some of the nodes that we don't want to move after our morph. So we're going to add those as anchor nodes. So we're going to select anchors here, make sure it's set to nodes, and just again right click and change the selection setting back to box, and then draw a box around the nodes that we do not want to move. We also don't want the nodes on the top edge here to move, or they need to remain where they are. So we just select those as well. So we've selected our nodes that we want to morph, representing the nodes in the perimeter of the hole. We've selected the anchor nodes that we don't want to move when we do our morphing operation, and HyperMesh has automatically selected the elements that are going to move when we apply our morph. So once we're happy with all that, we choose the direction that we want to morph it in here, which is Z and minus 30mm. Click OK. And here we have our hole is moved, the mesh is morphed with it according to our settings, and the anchor nodes have remained where they were. And once we're happy with that, we can press escape, and now we get the option to remesh if we wish. If you don't wish to remesh, you can always skip remesh, but what's shown here are the elements that are going to be remeshed based on our proximity selection, and we're just going to click remesh here on that particular setup. Now, the mesh that has come up doesn't look particularly great, and the reason for that is because if we go back out to elements and press J on the keyboard, we get the elements that are adjacent to those particular elements of this bulkhead, and we can see that there are some ridges and connectors here that are connected to those particular elements that have morphed. And you notice that some of the connector elements have stretched here in a way that is kind of undesirable. So there's a setting to kind of overcome this. So to get around that issue, you would simply need to unrealize the connectors in that area before you do the remesh operation, and then re-realize them afterwards to give you both a good mesh in that area and good connector connectivity. So we're going to move on to the final part of our morphing series here and look at volume morphing on this model. So we're going to morph the fuselage here in quite a significant way. We're going to move the pillar here between the cockpit and the cabin areas aft in 50 millimeters. And we want, during that morphing process, we want to adhere to the, as best we can, to the profile of the fuselage itself, so that we don't disturb those error lines. First thing I want to do is just turn off the rigids and connectors here on the display. They don't need to be part of that morphing process here. So we just go to the mask browser and click on hide on connectors, rigids and springs. So those are still in the model, but obviously we don't want them to be kind of on the display, but we do want them to be updated during that morphing process. And the way we make sure that particularly the connectors are updated is if we go to File Preferences here, under Morphing, we have the option under Morph Volumes to set the realization for connectors during the morph volume process. And we want to set that to unrealize and realize, so that whenever we make a change to the model, the connectors are updated to the local element connectivity. So I click unrealize and re-realize and then hit apply. OK for that. So we're now ready to create our morph volumes on this particular model that we need in order to do our morphing. So we click on volumes, click on enclose. And the first thing we need to do is just enclose the entire model, the morph volume. And as we do that, we can partition that morph volume here, as you can see in X, Y, and Z, according to what we think we might need later on. This can be changed at any time, but useful if we set them now to what we think we need. So we're going to choose 5 subregions here, so 4 partitions. And then we're going to click enclose on that. Just before we enclose that, you can also just set your buffer region here, so you can, currently the default is 10%, you can make that as tight as you wish at this point. And that will just bring that morph volume closer to the FE model. You can also create mid handles if you wish, rather than just handles on the at the vertices of the morph volume and subregions. So we're just going to accept that by clicking enclose. So we want to now position our partitions according to what we'll need for our volume morphing operations later. So we're going to go to the move icon here and change morph to adjust volumes. And then we're going to select the handles of the at the vertices of the partitions here. Now the handles are not shown on the screen at the moment for clarity, but if you go to the browser, select the handles menu there, and on A, you will get displayed on the screen all the handles at each of those vertices. But for our purposes here, we're going to keep them turned off. We know which handles we're going to be choosing. So we're going to draw a box by left mouse and just draw a box around the partition that we want to move, the first partition we want to move. We're going to click on the X-axis here, and we're just going to drag that to approximately be positioned within the cabin area here that we want that position to be based. Let's escape twice to deselect those handles, and then we choose a second partition and we move that to just forward of the pillars. So what we're creating here is we're creating a volume that encompasses a pillar that we want to move, and we also have a volume here which will contain the elements that we don't want to move when we do our morph operation, and we only want to move the elements in this local region here. So we press escape twice, select the handles of the next partition, move them now to the aft side of the pillar where we're moving. and we choose our last partition there, and we want it to move it just to the aft end of the first window here in the cabin area. So I'm just going to move this partition here ever so slightly so that it's forward of this rib down here, so that it also moves with the morph operation. So now we have our partitions positioned where we want them in order to do our morphing operation. I'm now going to just, to help retain the profile of the fuselage, we're going to move some of these handles here to better capture the profile of the fuselage. So just before we do that, let me just show you the tangency here, because that's kind of influencing, as you may have seen there, the movement of these particular handles. So we've got some of these tangents here under the edges icon, and these are dictating how the subregions kind of talk to one another, if you like, during the morphing operation. So where you have a green arrow spanning across subregions, then kind of what that means is that whatever morphing operations go on the left-hand side, for example, that will be reflected on the right-hand side through the tangency between those two domains. We don't want any of the elements downstream of this partition here to move, so we're actually going to just left-click on these arrows here and they will disappear, which means that any movements upstream of this partition will not be affected, will not affect the elements downstream. And we'll do the same with these arrows here. These edges, we don't want those to move, the elements to move upstream relative to the downstream morphing. So now when we go back to move and adjust our volume here at the end, and we move that down, we can see that that follows quite nicely the profile of, we can make that follow quite nicely the profile of the fuselage. Similarly here, we'll move this one up. And we're also going to move these two here just a little bit closer to that fuselage area. To get the best chance we can of maintaining that profile. And similarly down the bottom here, we'll move these four up. I think here we probably are okay in this region here because we're not really so concerned about the impact of what's going on upstream here. It's only the downstream area that we're concerned with. So we're now going to change the adjust volumes to morph. And we're now ready to try morphing our pillars in X. by 50 mil aft. And you can see that that moves the pillars, it moves all the ribs internally. And it also has changed the profile ever so slightly of this region here. If that's something that was of concern, then you could always morph that back to the CAD, or you can use the move tool again and just bring that down to in line with where you want it to be for your particular profile. You can see all the connectors have realized here, and everything is reconnected. That is our pillar between the cockpit and the cabin moved 50 mil and aft. And if we wanted to save that as a shape, we can simply click on the plus arrow, the plus icon here, and all of those shapes that took place as a result of that morph would be saved to a shape. Okay, that concludes the morphing session here. I hope that has been useful for you. Please get in touch if you have any further queries. Thank you. Another option we would like to show you with the morphing is the cyclical morphing that is possible within the morphing tools. For a component such as this, you can effectively morph one particular vein, in this particular case, of this model, and with the setup of the morphing, all the other veins will follow the same morphing changes. They'll all be reflected across the model. So I'll just show you how to set that up in this particular model. The first thing we need to do is we need to create a cylindrical coordinate system in this model. So we're just going to do that. First of all, we're going to create a node at the center of the model using the control key and clicking 3 points on this inside face here on this edge, and we press escape, and that gives us a node at the center of the model, on the center line of the model. We then go to the model ribbon and the systems, and we choose that node as our origin, and then we select from the pop-up here cylindrical coordinate system, and then we want the z-axis of that system to be pointing down the axis of this part, and we check that and find that that is the case, and so we simply accept that coordinate system. So we then need to change a setting in this particular model to allow us to the cyclical domains and handles to be set up correctly. So we go to the preferences menu, and the morphing option, and we scroll down to right near the bottom, and we have this curve tolerance here. That is a tolerance value for how the morphing tool detects curvature changes for partitioning. We're just going to increase that from the default of 8 to 10. We click OK. So we're now ready to create our morphing domains and handles. So if we go to the morph ribbon and we click on the little arrow here to get more options under morph, the first thing we just need to select is domains. And we want to create local domains on all elements. And we just click create. And that gives us all of our domains and handles around the model, particularly on the blades. And we then want to define symmetries for this model, cyclical symmetries. So we click on symmetries, we select our domains. We can just select them all. We select our system, which is the system that we just created. And we tell it the default axis for the symmetry here is the z-axis of that local system. And then we want to change the dimension here from circular symmetry to cyclical symmetry. We change the between all the veins from unilateral to multilateral. What that means is that we can choose any vein and make a change on it, and it will be reflected on all the other veins. With multilateral, if it's unilateral, you have to choose a specific vein, which would be selected upon creation. We then want to choose approximate here for our creation of our symmetry, and then we want to tell it the cyclical angle is actually going to be a frequency based on the number of veins, which we know to be 48. And then we click create on that. So the yellow entity here indicates that we have cyclical symmetry now on this particular model. And so now what we can do is we can just zoom in on any of these veins here. And we can start to choose to make some changes on that, and that will be reflected on all of the veins. So for example, if we click on move domains and we select the domain here, we can change that to offset here. And that allows us to select the arrow and define an offset, let's say -5. All of the domains will then be updated. The one that we've made the change in gets updated upon release. Delete. So the yellow entity here indicates that we have cyclic symmetry now on this model. So we now want to make some morphing changes to all of these veins in one go. We can simply do that by clicking on the free morphing tool, clicking on domains, zooming in on a domain here. We can choose a domain on the end here, for example. And we get a manipulator up, which we can then use to make changes to that particular vein. So for example, we may want to change the angle of that vein. By changing that one vein, all the veins get modified. Alternatively, we may wish to change the length of a vein, so we choose a domain again. And from the manipulator that pops up, we can choose the z-axis, two and a half, and all the veins will change length accordingly. So this is just a really useful tool to speed up geometry changes, again, without actually having any geometry to mesh. But you can introduce those changes using the existing mesh. And that covers the cyclical symmetry for morphing. Thank you for listening.